nowadays it is assumed that matter is made up of two things, two fundamental particles, and these two fundamental particles are number one quarks and leptons. Initially it was thought that neutrons and protons, these are fundamental particles, but these are not fundamental particles. Now there are other fundamental particles which we call quarks. Now these are called these are known as fundamental particles, and the neutrons and protons, these all baryons, basically they are made up of quarks. So what are the properties of the quarks? So quarks, the following are the properties of the quarks. Very first, the quarks have fractional charge. They have fractional charge. Before the discovery of the quark, it was thought that charge in the terms of unit of electrons, that everybody have a charge in the units of charge of 1 electron. So this is called quantization of charge. But these are the particles, the quarks are the particles which have fractional charge. They have charge of plus 2 by 3 charge of electron, plus 1 by 3 charge of electron, and minus also, and minus 2 by 3 charge of electron, and minus 1 by 3 charge of electron. So they have fractional charges. Then these quarks and these leptons, these both, they are point type structure. They are point like structure on the scale of 10 to the power minus 17 meter. Means if you have your scale of 10 to the power minus 17 meter, then these quarks and leptons both are point like structure. Means you cannot see the quarks and leptons by any of the today's microscope. So they are very small, and only so these quarks are called, that's why these quarks are called that the quarks are confined. Confined means this, we can see, we can observe the effect of these particles, but we cannot directly see these particles. That's the meaning of this confinement of quarks. That's the quarks are confined. Then these quarks, because they are fermions, and because they are fermions, so they have integral half spin, and so their spin is half integral. They have half integral spin. And the energy of the quarks, so because these quarks, these protons, neutrons, these baryons are made up of quarks, mesons are also made up of quarks. So how these quarks are bound inside these particles? So in these hadrons, we can say, so how they are. So basically there are many theories. One theory that these particles, their energy of the particles is the particle distance. So this may be equal to minus alpha r plus beta r. So there are two terms, competition between two terms, this inversely proportional to r and directly proportional to r. So these two terms confine the quarks. They don't allow the quarks to go out, and they don't allow the quarks to collapse. So this term constrains them to collapse, because when r decreases, this term dominates, and this term dominates means negative, energy becomes negative. So this becomes negative, then that means they cannot go much closer, and this term this basically this beta is of the order of 1 giga electron volt per Fermi. So when R increases, then this term, this will suppress, and the whole depends on this term. And energy, this is basically UR, this is binding energy, and this binding energy increases. So binding energy increases. Because of increase of energy, they cannot get out. Because let's do an example, like if we want to see the quarks, then at least the separation between these quarks must be of the order of the atoms. So what is the size of an atom? An atom, the size, let's assume the size of an atom is almost equal to, let's say, it's 1 angstrom, let's say. It's 1 angstrom. 1 angstrom. Size of the atom is 1 angstrom, as we assume. Then if size of the electron is 1 angstrom, then it means R must be equal to, if of the order of, so this implies R is of the order of 1 angstrom. इतना होना चाहिए at least. So if this is 1 angstrom, then what is this term? Then beta is 1 giga electron volt per Fermi. We convert it to in Fermi. Then what is this energy term? So we neglect this term. Then UR is almost equal to 10 की power 5 giga electron volt. Means so much of very high energy. So we need this much of energy to detect these quarks, and we today till date we don't have any accelerator having this much of energy. So this is the main constraint why we are not able to see the quarks experimentally. Only we observe their effects. Then there are types of the quarks, that how many type of quarks we can have. So you know the quarks, generally this is the way how I remember this. The quarks are U, D, S, and other is C, B, T. U means this name is up quark, D means down quark. They simply name. They are simply naming of different quarks. And S is strange, and C is charm, B is bottom, and T is top. So these are the name of the quarks. And these quarks, then term is charge on the quark. So what is the charge? On U quark, it is assumed that it has charge 2/3 charge of electron. D has charge -1/3 charge of electron. Same as is -1/3 charge of electron. And C, this is +2/3 charge of electron. B, -1/3 charge of electron. And T, +2/3 charge of electron. So this is the charge on this. Then next, what is the baryon number? So baryon number B, and these all have baryon number 1/3. These have baryon number 1/3. Then this is the charge. Then a quantity which you call isospin I for U and D. U and D, these makes pair. They form doublet. So their isospin is 1/2, and all are singlet. All are similar. Then I3 component, this I3 component is plus 1 by 2 and it is minus 1 by 2. Another, you can say this and this strangeness. Important factor is S. Strangeness, these have no strangeness, 0, and strangeness quantum number for S is minus 1, for all it is 0. All it is 0. So this is a chart. I will provide you notes for that. I will give you the PDF copy. But this you must memorize. Remember, this is UDS, up down strains, CBT. So how I initially remember it? We had a department that's called Center for Biotechnology. In this way, I remember, I memorized these things initially, but now I know. And then what about charge? Then ds, u has plus 2 by 3 and s has minus 1 by 3. This b bottom down means low charge, other have higher charges. So in this way you can remember these things. Then for our purpose, don't worry about this. Now you need not to worry about these three. We are not discussing, this is not in our syllabus. We will discuss all the hadrons. They are made up of these particles U, D and S. So we will do that. And this is their charge. We run this. And there comes Quarks model. What is Quarks model? Quarks model. Quarks model, it tells you that these baryons and mesons, they are, means hadrons, are made up of quarks. They are not no longer, they are not fundamental particles. They depends on they are made up of quarks. So how these baryons are made up of 3 quarks. These quarks are 3 quarks. Q, Q, Q. This Q represents quarks. And antibaryon are made up of antiquarks. Antibaryon are made up of antiquark. Every quark, this UDS and CBT, they have their antiparticle. Obviously, as we discussed in other particle case, that if we have a antiparticle of U, then that antiparticle, what we represent? We represent antiparticle of U is equal to U bar, D is equal to D bar, S is equal to S bar. So antiparticle of D, D bar, antiparticle of S, S bar. And the charge of the antiparticle is reversed. Baryon number is reversed. I3 component reversed, minus means it is minus. For antiparticle of U, it is minus 2 by 3e, it is minus 1 by 3, it is no change here. It is minus 1 by 2 and strangeness is 0. And same in case of antiparticle of strangeness, the charge becomes S bar. For S bar, charge becomes plus 1 by 3 and this is minus 1 by 3. This is 0, 0 and this becomes plus 1. So this is. So in case of baryons, they are made up of 3 quarks. It's a combination of 3 quarks, not quarks and antiquarks. There must be all 3 quarks. This is important. Means all 3 should be quarks. And if you want to plot antibaryon, means if you want to write any antibaryon, that is made up of Q bar, and Q bar. 3 particles. So this is the formation of baryons and antibaryons. All 3 must be anti-quark. And in all 3 must be quarks. So this is we will construct different Then how mesons? Why these three? Why these three baryons? Q, Q, Q. They have half integral spin, and 3 becomes, they means also have same half integral spin, because baryons have half integral spin. What about mesons? The spin of mesons is, because mesons are bosons, so they have integral spin. They have half integral spin, they have integral spin. So integral spin, so they are made up of one quark and one anti-quark. They are made up of one quark and one anti-quark. So it has plus half, let's assume plus half spin, it has minus half spin, and both cancels out, we make them zero spin. Or they can be one spin, mesons, plus half is equal to 1. So this is about the baryons and mesons. This is quark model, that baryons and mesons are made up of quarks, and this is the formula of their formation. Then now we will write neutron, proton, these baryons in terms of quarks, and same we will do with the mesons. So if you do, let's first construct the baryons. Baryons. How baryons? How this neutron, we will write something. First neutron, you must remember this. This is neutron, then proton, lambda, then sigma plus, sigma naught, sigma minus, then xi naught, xi minus, and omega minus. These are the baryons which we study. So what are their properties? They all baryons have baryon number B is equal to 1. Their baryon number is equal to 1. And then what about what is the charge? Charge on this Q. Charge, it has neutron has 0 charge, proton has plus 1, lambda, this is lambda naught 0, so plus 1, 0, minus 1, 0, minus 1, minus 1. This is the charge. Then strangeness, what is their strangeness? Their strangeness S is 0, 0, and this lambda, what is the strangeness of lambda? We must know this strangeness of lambda. This is also minus 1, and this is minus 1, minus 1, minus 1, minus 1, minus 1, and this strangeness is minus 2, and this is minus 2, and this is minus 3. So this is the strangeness, charge and strangeness. On the basis of charge and strangeness, can we construct them in the form of quarks? So see, if you want to know that what are the 3 quarks which includes in N, because these all are made up of, I earlier tell you, U, they are made up of U, B, S, only these 3. By this combination of these 3, we will find out that which are the quarks in concerned to the formation of neutrons, protons, and these all. So U, what is the charge on U? Plus 2 by 3, minus 1 by 3, minus 1 by 3 E. And what about strangeness? 0, 0, minus 1. Okay. So from this, because neutron and proton, they have 0 strangeness. They both have 0 strangeness. It means S will not be there in neutron and proton. So it is only made up of U and D. So what should be the combination of U and D in the formation of neutrons or protons? Like in case of neutron, if I want to make, so I have to make charge 0. This has plus 2 by 3 charge. So if I write it is equal to U, D, D. See, they all have S0. S0 means strangeness is 0. They have charge plus 2 by 3. It has charge plus 2 by 3. It has minus 1 by 3. Charge of electron E. I left that. Minus 1 by 3 E. So this is minus 2 by 3. This is plus 2 by 3. Total charge is 0. So it is so neutron can be represented as UDD. And if you want to represent proton, then how we can represent proton? So similarly, you want to represent proton. So proton can be represented as UUD. Why? Because U, it has plus 2 by 3, plus 2 by 3 and D minus 1 by 3 is equal to 1 unit of electron charge. So it has plus 1 charge. So this is plus 1 charge. So this is UDD, UUD. And if you want to write lambda, how we can write lambda? In case of lambda, what is S? Strangeness is minus 1. Means one quark must be, in lambda, one quark must be S. So one quark is S. And S has charge minus 1 by 3. S has charge minus 1 by 3. Other combination, so I have minus 2 by 3 charge. If I take U, then 1 is only because U has positive charge, D and S have negative charge. To neutralize, I must have taken U. So U, D, S. U, D, S. So what is this? UDS, you see, it has plus 2 by 3 charge, it has minus 1 by 3 charge, and it has minus 1 by 3 charge. And sum is 0. And strangeness, you want to strangeness 0, 0, minus 1, minus 1. So strangeness is minus 1. So in this way, we can form all the particles. Like, now I will do bit fast. I will not write this. And if you want to write sigma, then sigma plus, it has strangeness minus 1. Minus 1 strangeness means it has 1s. So 1 is s. And what about others? It must have positive charge. So it is UUS. Plus 2 by 3, plus 2 by 3, minus 1 by 3. And what about sigma naught? It has neutral. So sigma naught is same. UDS. Same lambda. Then sigma minus, because you must have negative charge. So it is DDS. Minus 1 by 3, minus 1 by 3, minus 1 by 3. Total charge minus 1. Then xi naught. In xi naught, you know there is minus 2s. So particles are made up of quarks, this, and baryons are made up of quarks, and antibaryons are made up of antiquarks. So we must have taken s. So these are minus 2, so 2s. First thing is 2s to make it minus 2. To make it minus 2. Then charge is negative. Yes, this one. So it is 0. Then it is 0 means this is minus 1 by 3, minus 1, minus 2 by 3. So we have to take USS, and in this case minus 1, minus 2, we take DSS. And simply, it is very simple. This omega minus have minus 3. Strangeness means 3s. S. This is about the formation of baryons in terms of quarks. So this is the neutron, proton, and these all you can see that. Next, this is about baryon. Then we construct mesons and do the same for mesons. Mesons. How mesons are made up of? So we have mesons like first mesons. If you want to plot mesons, they are Q and Q bar, quark and antiquark. Okay, combination of two. Then mesons are like you have pi plus, pi naught, pi minus, K plus, K naught, K minus, K naught bar, and eta naught. We will discuss these 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 mesons. Same, right, charge. What is the charge? Charge, it is plus 1, 0, minus 1. Obviously, it is plus 1 E here, but we leave that. This is plus 1, 0, minus 1, 0, and eta naught 0. What about strangeness? Strangeness, pi strangeness is 0, and this strangeness, its strangeness is plus 1, 1, minus 1, minus 1, 0. Now we have to form this by the combination of Q and R. So you have to construct pi plus. How we can make pi plus? If we take 1d and d bar, d have charge plus 1 by 3 and d have minus 1 by 3 and d bar also have plus 1 by 3, so they cancel out, charge becomes 0. So we have to make charge. So one thing, S is 0, so we have to use only U and D. We cannot use S, so we need not to use S. So how this combination becomes? So pi, let us assume we take U, we have to take plus charge, you have plus charge, and D bar. What is the charge on U? Plus 2 by 3. What is the charge on D bar? Plus 1 by 3. Total becomes 1. Very easy. And if we take pi naught can be made by two combinations. One is dd bar, one is dd bar, other is uu bar. See, both have S0 and dd bar minus 1 by 3, plus 1 by 3, 0, plus 2 by 3, minus 2 by 3, 0. So it's a mixture of these two, and this is minus 1, and to normalize it, we do it under root 2. 1 by root 2 dd bar minus uu bar. This is pi naught. And what about pi minus? Pi minus you must have negative charge, so pi minus is, you can represent pi minus by u bar d. Minus 2 by 3 plus 1 by 3 becomes minus 1. Then what is K plus? K plus, you know, 1 is strangeness. Strangeness is 1, it means S bar. It means it has S bar. And S bar, US bar. Where you have to take plus charge, plus 2 by 3, plus 1 by 3 equal to 1. And for K naught, you must have S bar because the S has strangeness minus 1. So you have to take S bar. So this is D S bar minus 1 by 3 plus 1 by 3 becomes 0, charge 0. Then K minus, this K minus, it is antiparticle of K plus. If you make it K minus, which is minus S, means S is as it is, a negative charge U bar S. K naught, it is antiparticle of, K naught bar is antiparticle of K naught, then it is D bar S. Simple. And eta naught, it can be combination of all DD bar, UU bar, SS bar. It can have all. So it becomes 1 by root 3 combination of DD bar, UU bar plus SS bar. So this is the way how mesons can be written in the form of quarks. So mesons constitutes, this is combination of